Good morning, dear my students. Welcome you all, my dear students, to Chemia channel. Today, let us discuss some questions. That is, you are all going to write NEET, IIT, MDA, and medical and lead courses conducted by Jipmer. In all entrance examinations, three different category questions you can face. First category, normal or AC level. Second category, moderate level. And the third one, difficult level questions. So, difficult level questions, they are indicating challenging problems based on twists and wide application of facts. So, today, let us discuss some questions based on this one, that is challenging problems. So let us read the question. First one. 40 ml of oxalic acid solution. What is that? Given that oxalic acid and its volume is known, that is 40 ml. So we know 40 ml oxalic acid. We have 40 ml oxalic acid. And we are going to treat this oxalic acid with 16 ml, 16 ml of 0.05 molarity capital M acidified potassium permanganate. So potassium permanganate is mixed with the acid. And its concentration is known 0.05 capital M. And its volume is also known, that is 16 ml. So from these sentence we can understand oxalic acid, its volume is known, but its concentration is unknown. Acidified potassium permanganate, its volume is known and its concentration is known. We have to find out the pH. Once more I will read the question. 40 ml of oxalic acid solution reacts with 16 ml of 0.05 capital M, that is molarity acidified potassium permanganate. What is the pH of oxalic acid used for the reaction? So, in the question, 40 ml oxalic acid and 16 ml acidified potassium permanganate. 40 ml oxalic acid, its concentration is unknown. But acidified potassium permanganate, its volume and concentration are known. 16 ml, 16 ml and 0.05 capital M molarity acidified potassium permanganate. What is the question? Find out the pH of the oxalic acid used for the reaction. So what is the pH of oxalic acid? Normally we are thinking, first question, that is ionic equation, and we can balance based on oxidation number method and half reaction method. That is explaining in the chapter redox reactions. And another one, stoichiometry, how many moles of electrons, how many moles of substances. And also another chapter, ionic equilibrium, that is the second part of the chapter, chemical equilibrium. So, based on these three chapters, our concepts from these chapters, we need to solve the problem. So, what we can do? First, we have to write the given data. That is KMnO4. What we can write? KMnO4. It is potassium permanganate. And it is acidified H plus treated with C2O4 2 minus gives Mn2 plus then we can write carbon dioxide. These are given in the question. So let us separate this equation into oxidation and reduction. In KMnO4 manganese has plus 7 or 7 plus oxidation stage, and this one Mn2 plus. So oxidation number decreases means addition of electron, because plus 7 becomes plus 2. Why? Because Mn7 plus has to add electrons. Then only it can become 2 plus. Therefore, first let us write Mn7 plus Mn2 plus. Here how many electrons? 5 electrons. Then only 7 becomes 2. 5 electrons added to Mn7 plus. In that place 7 plus becomes Mn2 plus. It is what? It is addition of electron is called reduction. Let us write here RDN means reduction. NF factor in it is 5. That is 5 moles of electrons. Second one, C2O4 changes to CO2. So we can here write C2O4 2 minus changes to carbon dioxide. That is here 0 oxidation state due to addition or removal. It removes electrons, that is extra 2 minus electrons they removed. As a result we get, that is a neutral compound carbon dioxide. Then here we can write OXDN, that is oxidation, then NF is equal to 2. But in oxygen and H plus ions are there, we have to balance even manganese. So how can we balance? First let us write two equations, that is equation 1 and equation 2. Then simultaneous equation methods, that means here 5 electrons, here 2 electrons. So can we cancel that one? Therefore multiply 2 with the first equation and 5 with the second equation. So 2 electron multiplied there, that is 2 Mn7 plus 10 electron gives 2 Mn2 plus. Okay. Similarly we can do 5 multiply with this one, that is 5 C2O4 2 minus gives 5 CO2 plus 10 electron. Then we can remove these electrons. In the last step we can write KMnO4 plus C2O4 2 minus plus H plus gives CO2 or Mn2 plus. Let us add the equation Mn2 plus carbon dioxide plus water. Here oxygen we can, and also other manganese also can be, we can balance using 5 and here 5. Then we can write oxygen 5 for 20, 20 plus 8 to 28. Here we have to write 10 because there are 5 to 10 carbon atoms, therefore 10 carbon dioxide. And also we can balance the oxygen. How can 5 for 20, 20 plus 8, 28. And here we can write a 10 to 20. Then we can write 8 H2O, 16 H plus. So make a shortcut method. Let us do this one by shortcut method by taking NF factor. So you can use this 2 given to KMnO4 and 5 supplied to oxalate. The remaining oxygen atoms you can balance by adding water molecule to the right side. And acetate potassium permanganate, therefore we can add H plus in the reactant side. In order to balance H plus, we can add a suitable number to water molecule. In that way we can maintain them equal. So next one. Here we just balance the equation only. Next let us go to find the concentration of oxalic acid. If you know the concentration of oxalic acid, from that one you can find the pH of the oxalic acid. So here milli equivalent of C2O4 is equal to milli equivalent of KMnO4. Here given in the question they have given NF factor NF factor into, and similarly volume into concentration factor is equal to, we can write NF factor into volume into concentration. Here in oxalate ion we can write NF factor 2 that we already discussed. And next one, volume of oxalic acid solution 40 ml, it is given in the question paper. And we don't know concentration, let us take it as yes. Next one, NF factor manganese 5 and volume is given as 16 and concentration is given 0.05. Then X is equal to 5 into 16 into 0.05 divided by 2 into 40. This one, 80 by 80. Okay. Into 0.05 means 5 by 100. That is 80 cancel, that we can write 0.05. Therefore, we got the concentration of oxalic acid is 0.05. What is pH? pH is negative logarithm to the base 10 hydrogen ion concentration. Here the acid is H2C2O4. Assume this acid is undergo complete ionization. That is, they have given in the question paper. Oxalic acid is weak. It undergoes partial ionization. Hence, the question paper they have given within the bracket, last part, question last part, in the bracket they have given that assume oxalic acid undergoes complete ionization. That means here H2C2O4 completely dissociated to give to H+. And the H+ ion concentration is here given that oxalic acid concentration is at 0.05. Therefore, it dissociates to give 2 into 0.05. Therefore, we can write it as 0.1. Then we can write pH is equal to negative log to the base 10, 0.1. That is negative log to the base 10 into 10 raised to minus 1. That we will get the value plus 1. Therefore, we can say the answer is 1. Did you understand? Once more I will say 40 ml oxalic acid only given. But it is treated with 16 ml what acidified potassium permanganate. But the question is, what is the pH of the oxalic acid? So you are mixing oxalic acid 40 ml with 16 ml acidified potassium permanganate. Acidified potassium permanganate concentration is 0.05. Based on these given data, we have to find out pH of the oxalic acid. So first we write ionic equation and try to separate oxidation and reduction. Then find out the number of electrons transferred during these two processes. Cross multiply in order to avoid the or remove complete number of electrons. Later you think about oxygen and hydrogen. Then suitable number you have to add. That is, in the right side you add first water molecule. Then you add or write suitable number to the water side in order to balance oxygen and the hydrogen. Then what we can do as per the rule, that is the concept milli-equivalent of oxalate ion is equal to milli-equivalent of potassium permanganate. Milli-equivalence we can find out by taking the NF factor into volume into concentration. In the second case, NF factor and volume into concentration, both are equal. NF factor for oxalic acid is 2. And the second one, volume is given in the question, that is 40. Concentration is unknown, therefore we can take it as X. And the next side, NF factor is 5 and the volume 16 given into concentration is known because that is also given in the question paper 0.05. From that one we can find X is equal to 0.05. Then we can write pH is equal to negative logarithm to the base 10 of H plus ion concentration. First we write the oxalic acid and it will dissociate to give how many moles of, how many H plus ions. So for that purpose, in the question paper they have given that oxalic acid undergoes complete ionization. Assume oxalic acid undergoes complete ionization. Then H2C2O4 gives 2H plus C2O4 2 minus. That is 2H plus means here we only X is equal to 0.05. But here it undergoes complete ionization, therefore we have to take 2H plus. That is 2 into 0.05, that will become 0.1. Let us write 0.1 as 1 by 10, and also we can write 10 raised to minus 1. Then write the equation pH is equal to negative logarithm to the base 10 of H plus ion concentration. H plus is 0.1 or 10 raised to minus 1 you can write. Then you will get the value plus 1 minus 1 log 10. Here also minus negative outside and within the bracket minus 1 log 10 minus into minus plus, so you can get the answer plus 1. That is the first question answer. Let us go to second question. It is that what is the percentage strength of 11.2 volume hydrogen peroxide? So that is a brief question, we can write it on the board. What is the percentage strength of within the bracket we can write it meaning percentage weight by volume of 11.2 volume H2O2 hydrogen peroxide. What do you mean by percentage strength? Strength means percentage strength. Percentage strength means how many gram in 100 ml. So we can write here percentage strength is equal to grams of hydrogen peroxide in 100 ml. We know the molar mass of hydrogen peroxide. Molar mass, that means mass of 1 mole. Mass of 1 mole H2O2 is equal to 1 hydrogen 1, 2 hydrogen 2, oxygen 16 into 2 32, 32 plus 2 34 gram. It means 34 gram hydrogen peroxide in 1000 ml or 1 liter solution. Or we can say 1000 ml solution has 34 gram, then 1 ml has 34 by 1000, then 100 ml has 34 by 1000 into 100, that is 3.4 gram. Therefore, answer is 3.4 gram. What is the question? What is the percentage strength of 11.2 VH2O2? So, percentage strength means gram of hydrogen peroxide in 100 ml. But mass of 1 mole hydrogen peroxide, we know its mass is molar mass, that is 34 gram. 34 gram has, that is 34 gram hydrogen peroxide is present in 1000 milliliter or 1 liter solution, or we can think 1000 ml solution has 34 gram. If so, 1 ml means 34 by 1000, then 100 ml means 34 by 1000 into 100. 100 and 1000 can be cancelled. We will get 10. That is 34 by 10 means 3.4 gram. Okay. Let us go to next question. .5 gram lead oxide. So we can write like this. PbO and 3.2 gram hydrochloric acid. So 6.5 gram and next one 3.2 gram hydrochloric acid produce PbO, lead oxide, lead chloride and PbCl2 and water. Which of the reactant is completely consumed in the reaction? Question once more I will read. 6.5 gram lead oxide is treated with a 3.2 gram hydrochloric acid produce lead chloride and water. In this reaction, which one of the reactant, that means either lead oxide or hydrochloric acid, is completely used, completely consumed during the reaction? What is the meaning of that one? Completely consumed reactant, limiting reactant or limiting reagent. So from this one we can find, first of all, we write the equation, then balance the equation. Based on that one only we can find which is the limiting reagent. Here we can write PbO plus HCl gives PbCl2 plus H2O. Here 2 chlorine, therefore we have to multiply HCl by 2. Hydrogen 2, oxygen 1, lead 1. Equation is balanced. It means 1 mole require 2 mole HCl. 1 mole require 2 mole HCl. But in the question paper they have given mass only, that means 6.5 gram and 3.2 gram. So we can write number of moles of PbO is equal to number of moles of lead oxide is equal to 6.5 gram mass. How can we find number of moles? Mass by molar mass. Mass given 6.5 gram and molar mass 223 is equal to 0.029 mole you will get. Similarly, we can find number of moles of HCl. That is, they are also same mass by molar mass. Mass is given 3.2 gram divided by HCl 36.5 gram, 0.087 mole. So let us say number of moles given in the question paper 0.029 mole lead oxide and 0.087 mole HCl. But as per equation, that means the balanced equation, 1 mole lead oxide require 2 mole HCl. If so, here how many moles they require? Number of moles of lead oxide 0.029. Number of moles of HCl, what is that? 2 HCl. So 1 mole lead oxide require 2 mole HCl. But here how many? 0.029. Then how many moles of HCl require? 2 into 0.029. Yes or no? If so, 0.058. But HCl 0.087 mole, which is larger one. 0.087 mole HCl is small quantity. That is given in the question paper. But require only how much quantity? 0.058. Therefore, we can say lead oxide is completely consumed. That means completely used up in the reaction. The HCl become balanced. Therefore, lead oxide is the limiting reagent. So, answer is 0.029 moles of lead oxide is the right answer. Clear? Yes. So, in the question paper, they have given only 6.5 gram lead oxide is treated with a 3.2 gram hydrochloric acid. Products are lead chloride and water. So we can write 6.5 gram PbO and a 3.2 gram HCl. But we write the same equation and make it balance. So 1 mole lead oxide require 2 mole HCl. Number of moles of lead oxide in the question paper. That means the given data. Based on that one we can find number of moles of PbO is equal to 6.5 gram divided by 223. Mass by molar mass. Lead oxide molar mass is 223. 6.5 by 223 is equal to 0.029 moles of PbO. And the second one, number of moles of HCl, 3.2 divided by 36.5, that is 0.087 mole. As per equation, 1 mole requires 2 mole. But here, number of moles of HCl greater, that means 0.058 enough. Twice of 1 mole PbO require 2 mole. Then 0.029 more PbO require twice of that amount, because 1 is to 2. Then its twice is 0.058. But in the question paper they have given that excess quantity. That means more quantity. Therefore HCl becomes balanced. Lead oxide is completely used up in the reaction. Okay. Next question. The conversion of oxygen to ozone occurs. The conversion of oxygen to ozone occurs to the extent of 15% only. So, oxygen changed it to ozone, how much percent? 15% only. The mass of ozone that can be prepared from 67.2 liter of oxygen. If so, 67.2 liter from this oxygen, we have to find out the mass. That means the mass of ozone that can be prepared. How much quantity of ozone can be obtained from this amount of oxygen, 67.2 liter. They gave only one data. That is, oxygen changed to ozone extended 15% only. But they are asking how much quantity of, or what is the mass of ozone that you can collect from 67.2 liter oxygen. So, here also we have to write the equation and make it balance. First we write O2 gives O3, 3 here, 2 there. Equation is balanced. That means 3 moles oxygen can give how many moles? 2 moles of ozone only. So we can write 3 can give 2, if so 1 can give 2 by 3. But the extent of 15%. But total number of moles of oxygen here 3. Then 2 by 3 into 15 by 100 into 3 cancelled. That is equal to, we can write 0.3 mole. But we have to find out the mass. We don't want moles. Because in the question they are asking how much quantity of ozone. Or what is the mass of ozone? But here we got only 0.3 mole ozone. How can we find the mass of ozone? Mass means number of moles into molar mass. Previous problems we found number of moles from mass and molar mass. Number of moles is equal to mass divided by molar mass. Here mass is equal to number of moles into molar mass, that is 0.3 into ozone, its molecular mass is 48. 48 into 3, 144. Change one place, that is 14.4 gram ozone that you can collect. Once more I will explain. Here oxygen converted into ozone. You are studying in which chapter means P block elements. In that one 16th group elements, oxygen, sulfur, selenium, tellurium, polonium. In that ozone is an allotrope of oxygen, Siemens ozonizer, ozone preparation and its reaction, chemical reactions, oxidizing agent. So from that part they can ask, because you are already learning more about ozone in that lesson, and also you are studying stoichiometry, and also you know how to change number of moles to mass and mass into number of moles. So they can ask such a questions from this part. That is 3 or 2 gives 2 or 3. That is 3 moles oxygen can give 2 moles. If so, 1 mole, how many? 2 by 3. But the extent of formation given, that is 15% only. Therefore, we can think for 1 mole 2 by 3 into 15%, but for 3 mole we have to take. Okay. 1, 2 by 3 and 3 mole extent of formation 2 by 3 into 15% into 3. 2 by 3 into 15% means 15 by 100 into 3. 3 cancel. 2 into 15, 30. 30 by 100 means 0.3. That is 3 by 10. So we can say 0.3 mole ozone is obtained in this reaction. But they ask the question, that is mass of ozone is obtained from which 67.2 liters. But we can think like this only. We don't want volume. Therefore, we can say mass is equal to number of moles into molar mass. Number of moles is 0.3 into molar mass 48 multiply 144. That is 14.4 gram. So you may spend the time thinking about 67.2 liters. Similarly, previous question also like that. 11.2 volume hydrogen peroxide. So simply you are spending the time thinking and the relationship or equations. So simply spending time only. So you are not getting clear. Therefore, we should by heart or learn or make clear concepts in all lessons. Then you can solve the problem easily. So what we found, mass is equal to number of moles into molar mass. Next question, RH2 ion exchange resin. RH2 ion exchange resin can replace Ca2 plus ions in hard water. Chapter S block elements. Hardness of water, soft water, hard water. Have you heard? Yes. In that lesson you are studying more about the hardness. So from that part you know that the concentration solutions parts per million, parts per billion, molarity, mole fraction, molality, etc. So they can relate these two chapters and they can ask a problem. That is this problem. RH2 ion exchange resin can replace Ca2 plus ions in hard water as. So we can write the equation. Ion exchange resin, that is RH2. It can replace Ca2 plus ions from hard water. Therefore, we will get RH2 replace, that is Ca2 plus, to form RCa. Then we will get 2H plus. Calcium valency 2. Alkyl group valency 1. Therefore, here alkyl RCa. Here RH2 2 hydrogen. But this alkyl group is extensive resin general representation. In order to avoid such a misunderstanding, that's why I told RH2 2 hydrogen atoms there and Ca2 plus. Because divalent, that means for example dialkyl calcium, organometallic compound. Magnesium, dialkyl magnesium, because magnesium has 2 valency, therefore 2 alkyl groups are monovalent. To avoid such a confusion, this R stands for resin general representation. Then we can write RCa enough and 2H plus ions, because this resin contains 2H plus ions and it is removed out and we will get 2H plus. And Ca2 plus we will get RCa. Then remaining question, is 1 liter of hot water after passing through RH2? Suppose you are passing 1 liter of hot water through ion exchange resin. After that, when we take the pH value, the water, its pH becomes 3. Then hardness in ppm, parts per million, of Ca2 plus ion. Question once more I will read. Ion exchange resin, general representation RH2, can replace Ca2 plus ions in hot water. Hot water contains calcium ions, magnesium ions. Okay, so this ion exchange resin can remove calcium ions from hot water. So when we remove calcium, magnesium ions, water becomes soft. So they can produce ready lather with the soap. Therefore, Ca2 plus ions completely removed. And the equation is RH2 plus Ca2 plus gives RCa plus 2H plus. Suppose we are passing 1 liter water through ion exchange resin. And after passing through RH2 has pH becomes, the pH of water becomes 3. If so, what is the hardness of water? So what we can think? Options they can give A 20, B 10, C 40, D 100. Previous questions I did not say options because you want to get the clear concept and how to solve. That's only because when we know the exact answer, we don't need other options. So how to solve the problems? What is the concept behind it? In order to make it thorough, you just need only the concept behind the problems only. So I did not explain because it spent more time. That's why I did not write the options. But in it we can write because size and also we can give sufficient explanations. A20, B10, C40, D100. How can we solve this one? Given that H plus, that is pH is equal to 3. If pH is equal to 3, H plus is equal to 10 raised to minus 3. You know, pH is negative logarithm to the base 10 of H plus ions. So when we put 10 raised to minus 3 here, you will get the value 3. Base 10 numbers. Logarithm is X plus base 10 numbers because 10 base numbers. That's why we can say if pH is 3, H plus ions 10 raised to minus 3. And also we can write calcium 2 plus, here we can write the calcium 2 plus concentration choice. That means 2 H plus is getting there. Because RH2 1 mole, it produces 2 moles of H plus. Therefore, calcium here Ca only. That's why we can say 1 by 2 into 10 raised to minus 3. But we want mass because parts per million it is 10 raised to 6 and in percentage and on the basis of mass of the given substances only. So we want to change this number of moles to mass. Therefore, mass is equal to 1 by 2 into 10 raised to minus 3 into, what is that, 40? That is 1 by 2 into 10 raised to minus 3 into 40 means atomic mass of calcium. What is 40? Atomic mass of calcium. Therefore, we can say hardness of water in ppm is equal to 1 by 2 into 10 raised to minus 3 into 40 parts per million. Therefore, 10 raised to 6 divided by 10 raised to 3. Therefore, 1 by 2 into 10 raised to minus 3 into 40 into 10 raised to 6 divided by 1 liter, that is 10 raised to 3. Then we can cancel these two, 10 raised to 6, 10 raised to 3, 10 raised to 3 and these two becomes 0. 1 by 2 into 40 becomes 20 ppm. So have to practice more and more, then only we will get a speech. If we will get a speech with accuracy. Speed and accuracy are the two main things which we have to employ during examination time. So to make speed and to make more accurate answer, we prepare thoroughly. First to make clear the concept. Read and read again and make the concept clearly. After that, start to do simple problems. Then some difficult. Then most difficult. So in that level, you can improve your level. Level 1, level 2, level 3, like that. So here in the question paper, they have given that RH2 ion exchange resin can replace Ca2 plus ions in hot water as the equation RH2 plus Ca2 plus gives RCa plus 2H plus. If 1 liter of hot water after passing through iron exchange resin has its pH becomes 3, then hardness in ppm of Ca2 plus iodine is given that A20, B10, C40 and D100. So they have given that pH is equal to 3. Then we can think H plus sign concentration 10 raised to minus 3. Explanation this one. pH is equal to negative logarithm to the base 10 of H plus ions. So we can change H plus ions to, in terms of strength or concentration, we can change it as 10 raised to minus 3 molarity, mole per liter. But in the equation Ca2 plus 1 and 2H plus twice. Therefore, Ca2 plus number of moles we can find by 1 by 2 into 10 raised to minus 3. Then what is mass? Number of moles into atomic mass. Here calcium is an element, but in water it exists as ions. So its atomic mass is 40. Then hardness in terms of ppm is equal to 1 by 2 into 10 raised to minus 3 into 40 into 10 raised to 6 divided by 10 raised to 3. Both can be cancelled. You will get 10 raised to 3 and 10 raised to minus 3 into 10 raised to 3 becomes 0. Remaining 1 by 2 and 40. Therefore, you will get 20 ppm. In competitive examinations, you can solve this type of, that means simple solving numbers only they will give you. Simple numbers only they will give you. But how to get in the final step, that is the most important thing. That's why I told it, do simple normal questions and gradually you have to increase your level, that is somewhat moderate level. Finally, you practice more and more difficult questions. So, large number they will not give because we have only small time. So, within that time we have to think, we have to write the step, and finally we have to use division, multiplication. So, they know that one. That's why they will give simple numbers. If you will get the concepts, you will get the equation, then you can simplify that one. So that time is enough. So here, today let us conclude. We discussed some questions which are important for NEET, IIT, MBA and also Jipmer medical and leader courses. Prepare well and may God bless you to get best result for this type of all competitive examinations. Thank you, dear my all students.